Sometimes graphing is not the easiest way to solve a system of equations, especially when your answers contain fractions. With the substitution method, usually you want to find one equation that has a variable isolated. Notice how we have an x equals in that first equation. We take that first equation, since it's isolated for x, and substitute it in for x in the second equation. The second equation is negative 7 times x, which I'll leave out, plus y is equal to negative 31. Well, the x that we're substituting in is 10y plus 34, which is the other equation. Now we have one equation containing just y, which we can solve. First we distribute to get negative 70y minus 238 plus y is equal to negative 31. And then we will combine like terms. This will give us negative 69y minus 238 equals negative 31. Notice I'm doing one thing per line. I'm going to add 238 to each side of this equation, and that will give me negative 69y is equal to 207, which happens to go in evenly. When you divide each side by negative 69, you end up getting y is equal to negative 3. Now do not stop there just because, hey, I found a value of y. You need an x and a y value to go with this. So that's where we go and take this value of y and substitute it into either of the equations up above. Since we're solving for x, the x equals equation is really the one that you want to substitute into. So 10 times negative 3, that's negative 30, plus 34 makes 4. Now some people like to write their solutions this way and just identify what x and y are. But technically, when you're finding the solution to a system, you are finding the point where those two lines intersect. So it is actually more correct to write this solution set as an ordered pair. In this next problem, we can see that y has been isolated in the second equation, so we'd like to take the value of y from that second equation and substitute it into the first equation up above. That first equation then becomes 5x minus 2 times input is equal to 10, and that input is x minus 1. We'll then distribute and solve this equation. We will have 5x minus 2x plus 2 is equal to 10. Combining like terms on the left gives us 3x, and I'm going to save a step and subtract that 2 on each side to get 8. So we can see that x is going to equal 8/3. We don't like fractions, but hey, we're going to have to deal with it here. Let's take this 8/3, substitute it in for y. Y is going to equal 8/3 minus 1. Well, we'd prefer to think of that as 8/3 minus 3/3, and therefore the value of y that we're seeking is going to be 5/3. So our solution set is the point 8/3 comma 5/3, and make sure that the x is listed first because coordinate points are listed in x comma y format. In this third problem, we'd like to use substitution, but we don't see an x equals or y equals directly. But notice how the x is by itself in the first equation, without a coefficient. That tells me it would be easiest to isolate the x, subtracting 4 on each side, or 4y on each side, to have x equals negative 4y plus 8. And I would then use that to substitute into the second equation. So that will give us 3 times input equals 3 minus 12y, and that input is our substitution, the negative 4y plus 8, which we're going to do some distribution here. We will have negative 12y plus 24 equals 3 minus 12y. Well, you might just start to see something strange happening here. If we try to get all the y's on the same side by adding 12y to each side, all the y's disappear and we have 24 equals 3, which is a contradiction. This cannot occur. Therefore, there is no solution to this system of equations. Now, had we arrived at a true statement, such as 24 equals 24 or 3 equals 3, then we would have said all real numbers is the solution set. We don't always have a nice neat x, y point where two lines intersect, because sometimes the two lines or equations that we're dealing with reference parallel lines, and sometimes they represent two lines that coincide with each other when you have all real numbers as your solution set.